Welcome to Study Loop.
For this problem on the topic of waves and sound, we are given a source of sound which is located at the center of two concentric spheres, as shown in the diagram. Now the source is emitting sound uniformly in all directions, and we have three small patches as shown on the spheres. Now we know the same sound power passes through each patch, and we know the sound power that the source is producing. We are also given the radii of the concentric spheres and are asked to determine the sound intensity at each of the three patches, as well as the area of each patch. Now, the source emits sound uniformly in all directions, so the sound intensity I at any distance r is given by the equation I is equal to the sound power divided by the surface area of the spherical surface 4 pi r squared. Now patches 1 and 2 are at the same distance from the source of the sound, so the sound intensity at each location is the same. That is, I1 is equal to I2. Patch 3 is further from the sound source, so intensity I3 will be smaller for points on that patch. Now patch 1 and 2 have equal intensities, each of which are greater than intensity of patch 3. So the sound intensity at the inner spherical surface, we'll call IA, is equal to the sound power passing through that surface divided by the surface area of that surface, 4 pi Ra squared. And this is the inner surface. Now this is a sound power of 2.3 watts divided by the surface area, which is 4 pi times the inner radius, 0.6 meters squared, which gives us the intensity through the inner surface to be 0.51 watts per square meter. Now the intensity is the same through all points on the inner surface, since all points are equidistant from the sound source. And therefore, the sound intensity at each of the two patches, 1 and 2, are the same. So I1 is equal to I2 is 0.51 watts per square meter. Now we are left to solve for the sound intensity at patch 3, which lies on the outer sphere. At the outer spherical surface, we have sound intensity IB to be the sound power P divided by the surface area 4 pi r B squared. This is the same sound power of 2.3 watts divided by 4 pi, and we know the outer radius is 0.8 meters, and that's squared. So calculating, we get the intensity through the outer surface to be 0.29 watts per square meter. Now, since the intensity is the same at all points in the outer surface, we get the sound intensity at patch 3, I3, to be 0.29 watts per square meter. So now we have the sound intensity for each of the three patches. Next, we want to find the area of each patch. Now the area of the patch is given as the sound power divided by the intensity, and we can now find the area since we are given the sound power. So for patch 1, we have area A1 is equal to the sound power P over the intensity I1. And this is 1.8 times 10 to the minus 3 watts over 0.51 watts per square meter. And that's an area of 3.5 times 10 to the minus 3 square meters. The area of patch 2, we'll call it A2, is equal to the sound power divided by the intensity I2. And this is the same sound power, 1.8 times 10 to the minus 3 watts divided by the same intensity. Patches I1 and I2 have the same intensity, which is 0.51 watts per square meter, which gives us the area, the surface area, to be 3.5 times 10 to the minus 3 square meters. Finally, we have patch 3, which has a surface area, A3, which is the sound power again divided by the intensity on that patch, I3. So this is again 1.8 times 10 to the minus 3 watts divided by the intensity now on patch 3 on the outer sphere is 0.29 watts per square meter. So calculating, we get the area A3 to be 6.2 times 10 to the minus 3 meters squared. So now we have our areas for each of the 3 patches.